Today we're going to use Compunetics to fit our first set of kinetic data. If we have this chemical system where we have A plus B reacts to make C, and then we also have A plus B reacts to make D, to transfer this system into Compunetics, we want to input the individual elementary reactions. So we have A plus B reacting to make C, and then we click add term. So now currently we have a model that represents this first step, and now we want to add A plus B as our reactants and D as our products to the model. And now we have a full model that represents this chemical system. Now we're ready to upload our data, and we have this example data in a datasheet template that Compunetics requires, and this is found in the Compunetics zip file. So we have our time in minutes, and then we have the species concentration in molar at each of these time points for A, C and D. We also have a corresponding error for each of the sample measurements in A, C and D as well. So now if we click upload data and plot, then we can upload this example data. Straight away the data is visualized in Compunetics, and you can choose which sets of data you want to visualize by checking and unchecking these data boxes. But we want to check with errors, which means that we can visualize the error bars and also will fit the kinetics with errors as well. The last thing that we have to do is to input the initial concentrations. So in this particular example we have 1 molar of our species A and 1.1 molar of species B. So now we have everything that we need to fit kinetics. We have our model, we have our reaction data, and we have our initial concentrations. So now we're ready to click fit kinetics. So what the algorithm is doing in Compunetics is it's trying to fit these ODEs, which stands for ordinary differential equations, which are essentially just kinetic curves. It's trying to fit these kinetic curves to the experimental data. After the curves have converged to the experimental data, it then attempts to fit the errors as well. So it's trying to find the maximum error in the rate constants. So pretty quickly we've achieved our rate constants for this set of data. So we have K1 and K2 as well as the corresponding error measurements. So now we can choose whether or not we want to visualize these ODEs. We can also visualize the concentration of B and how that changes over time because this concentration is inferred. And what we're ready to do now is extract plots. So extracting plots extracts the curve data to an Excel file, so then you can plot this and graph this in other software, so like Excel or Origin, so you can present your results elsewhere. But also what we can do is click on K area errors. So now because we have our error in our K values, we can visualize the maximum area error where this ODE curve can lie. So these curves can lie anywhere in the shaded area. After we've finished with all of our fitting, we can deselect our data, and then we can try to visualize how this experiment will proceed at different concentrations. So because we have our rate constants, we can see how this reaction would proceed at, let's say, 1.5 molar of species B. Press enter, and you can see that the reaction profile changes. And then we can do the same for species A, and the reaction profile changes again. So this is just one of the many simulation tools that Compunetics offers. I hope that this has helped, and please follow us on Twitter and LinkedIn, and send us an email if you require any help. Thanks for watching. Bye.